Hello, awesome CC3 students. It's Miss Angel with your lesson for today on rate of change and points and graphs and this whole thing called slope. So I am not as high tech as Mr. Adams. I'm a little more old school. So you really don't need a worksheet or anything to follow along today, just a piece of paper, or you can just listen. So in the video from Monday, Mr. Adams was looking at a worksheet where you were given a point and you were given a rate of change, and then you were given a table to fill in. So we're not going to look at the table so much as we're just going to look at the points and the rates of change. So if you remember, this all has to do with things called linear functions, but we don't have the function on these examples. We're just focusing on if you're given a point, and you're given a rate of change, can you go find the other points, okay, on this line that are solutions to the function. So I have some blank coordinate planes here. So I guess I should probably put in some coordinates, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Probably should have done that before I started the video, but I won't. Okay, so in our first example, you are given the point 0, 2. So that means that is a solution point. That's part of your function. So you're going to start with that. 0, 2 is right there on the y-axis. Okay, now your rate of change is basically telling you how to get to the next solution point. So in a table, what is this telling you? So I know in the video, Mr. Adams was looking at the change in x first, but when you get to Algebra 1, your Algebra 1 teachers are always going to refer to it as change in y over change in x, which means we're going to look at the change in y first in this video instead of the x change. But don't worry, you'll catch on pretty quickly. So a change of 1 means that I'm increasing by 1 each time. That's actually what that means. So in a table, if my point was 0, 2, here's the y value. My next y value in the table would be 2 plus 1 or 3. And then the next would be 4 and 5 and 6. So what does that look like on a graph? Well, y increases as you move up a graph. This is 2, 3, 4, 5, 6. So if I already know that the next point is going to be 3, I know that this means I'm going to be moving up 1 on my graph. So that means to get from this point to the next point, I'm going to move up 1. Okay, now that's not where my next point is, because you also have to account for the change in x. A positive 3 means I'm adding 3 each time. So if my current value is 0, 0 plus 3 is 3. So I'm basically going from 0 to 3, or I'm going to the right 3. So I went up 1, I'm going to go 1, 2, 3 to the right, and that leads me to my next point. Now in our IXL practice today, that's all you'll have to do, but for good practice, I make my students find every possible point that they can. So let's keep going. We're going to keep that rate of change going. To get to the next point, I would add 1 again, which means I'm going up 1, and add 3 to the x, which means I'm going 3 to the right. And that seems to have taken me to the edge of my coordinate plane. But you might notice, if I were to connect this in a line, doesn't it look like there are points over here that we haven't found yet? So that's how, what Mr. Adams pointed out, you can actually reverse the order, because if you're moving from left to right in a table, you might be adding 1. But if I move from right to left in a table, the opposite is subtracting 1. How do I go from 1, 2, 3, 4. How do I go from 4 to 2? Well, I subtract, 4 to 3, I subtract 1. How do I go from 3 to 2? I subtract 1. So it depends on the way that you're looking at it. Bottom line, you can go the opposite direction. Instead of going up 1, I can go down 1. And instead of going right 3, I can go left 3. And it takes you to another point on the graph. Same thing, I can go down 1. Because I make my students ask any of my algebra students, they find every single point. And right 3, 1, 2, 3. And it takes you to another point. Now my graph isn't exact, but you can tell that this kind of forms a line here, right? Can you tell? Thank you for those of you who are like, yeah, Miss Angel, I can tell, right? That's because this is called a linear function and it has a constant rate of change. Now I'm going to leave this up here because we're going to do a second example and we're going to compare the two graphs, okay? So I'm going to make some space down here. Adding in my coordinates, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. Okay. Notice how in the second example, we're starting with the same point. We're starting at 0, 2. This time, though, our rate of change is 3, but 3 doesn't show both of the changes. It only shows one of them. So we're going to rewrite this as a fraction 3 over 1 because it means 3 wholes. Okay, let's start with our change in y. Our change in y over here was that we were going to increase 1. So our next point would have been 3 because 2 plus 1 is 3. But over here, it looks like our change in y is increasing 3. So if I start at 2, 2 plus 3 is 5, which means I'm going up 1, 2, 3 to where y is 5. So this means I'm going to go up 3. Next is my change in x. It looks like my change in x is a positive 1. So if I start at 0, I'm going to add 1. Going from 0 to 1 means I'm going right 1. So I went up 3, right 1, very similar to what happened over here. All right, and it looks like I can't really keep going in that direction because I've run out of y values on this graph. So we're going to reverse it. Instead of going up 3 and right 1, now let's go down 3, 1, 2, 3, and left 1. And that takes you to another point. It looks like I can find one more point on this line. Down 3, 1, 2, 3, and left 1. Come here, pen. 1. Okay, and I think I'm out of space. But you can tell how these kind of form a line. Oh, that wasn't very good. So I'm just going to pretend like that point was over there. I guess this is the benefit of using modern technology, isn't it? But you get the idea. Okay, it's not pretty, but it works. All right. Now, why did I choose these two examples? Well, you might notice that 1/3 and 3 are actually reciprocals of each other. Also, they contain similar numbers. Like here, my change in y was 1. Here, my change in x was 1. Here, my change in x was 3. My change in y is 3. Here's why I wanted to choose these two, because today we're going to look at examples that deal with this thing right here called slope. I'm sure you've heard of slope before because you have seen it in your 8th grade math classes. Slope is the same ratio as rate of change. Slope is change in y to change in x. But here's the difference. We don't call it rate of change because slope refers to something very specific. Slope refers to the steepness of a line. Steepness means kind of like your angle of elevation. So how steep means if I were to walk up a hill, the steeper that hill is, the harder it is for me to walk. So think about it like this. If I'm going to start at the bottom of both of these mountains, pretend like these are steep slopes, right? Ha, slope, what? Anyways, if I'm starting down here and I'm gonna walk up this mountain versus if I start down here and walk up this mountain, which one do you think is going to be more difficult? I'm gonna say this one. Why? Because this is more steep. It's almost vertical, which means that's gonna be so much harder to walk up than this one is less steep. Now, here's the interesting part about this. What was the slope, rate of change, slope of this line? The slope of this line was 1/3. What was the slope, rate of change, of this line? The slope here was 3. Which one's greater? Isn't 3 greater than 1/3? And isn't the slope of 3 more steep than the slope of 1/3? Yeah, these are all things that you're going to discover the deeper you get into linear functions, but slope is how steep a line is. So the larger the number, the steeper the line. So imagine like a slope of 100 compared to a slope of 1/8. The slope of 100 would be like a crazy steep line. You're at the bottom of that. You almost have to rock climb up that wall. Whereas slope of 1/8 is almost like you're walking on flat land. So the larger the number, the steeper the slope. Now notice both of these are positive examples. So we're going to do one more example before we jump into your IXL. Let's take a look at what it looks like when you have negative examples. Okay, here are our next two examples. So this time we're going to start at the point 0.04. Over here we have a rate of change of -2/5. Over here we have a rate of change of -5. And let's see what happens when we deal with some negatives. So here we go. Starting at 0, 1, 2, 3, 4. There's our first point. What does a negative rate of change mean? Well, Mr. Adams kind of touched on this, but a negative rate of change means either my change in y is subtracting each time or my change in x is subtracting each time. Now, I have a little saying that I use with my Algebra 1 kids. The rate of change is always right. Now, what that means is basically to start your graph, always account for going right, which means the negative belongs to the numerator, or give that negative to your y value so your x value stays the same. Let me show you what I mean. In other words, I'm going to write this as -2 and +5, because that will allow me to move right 5 and down 2. Now, you don't have to do it that way. In fact, as you notice, when we reverse the order, we'll end up going up 5 or up 2 and left 5. But it just helps you stay, or helps keeping you from being too confused. So the rate of change is always right. So if it's negative, that means you're going down and right. And if it's positive, go up and right. That might help you, it might not. Okay, so using the rate of change, because it's negative, I'm going to go down 2, which means I'm subtracting 2 from my y. So my 4 becomes 2. And I'm adding 5 to my x. So my 0 becomes 5. 1, 2, 3, 4, 5. And that takes me to another point on my line. And from here on a larger coordinate plane, you could keep going down to right 5, down to right 5. But I'm already out of room. So let's go ahead and reverse it. And you'll see how if you had given the negative to the x, it would have still worked. Instead of going down 2, let's go up 2, which means I'm going to go left 5. 1, 2, 3, 4, 5. That takes me to my third point on the line. And you could keep going in that direction. But either way, you've got yourself a line with a slope of -2/5. Not perfect, but you get the idea. I would suggest using a straight edge if you can. Whatever. I got a little bump in my line here. All right, here we go. Let's see if I can make that a little bit straighter. There we go. All right, but you get the idea. We got ourselves a line. That's going to bug me that it's not exactly straight, but oh well. Okay, over here, same idea. Starting at 0.4. Where's my purple pin? 1, 2, 3, 4. This time my slope is -5. So let's go ahead and change that into a fraction. And again, since the rate of change is always right, go ahead and just give that negative to the numerator. -5 over +1, which means I'm going to go right 1 after I go down 5. So from here, my y, which started at 4, I'm taking 5 away, which means I'm going to go down 1, 2, 3, 4, 5, and I end up at -1. And my x, which started at 0, I'm adding 1 to it, which means I end up at 1. And there's my next point. I think I have enough room to go one more time. 1, 2, 3, 4, 5. Right 1. And it doesn't look like I have enough room to reverse it. So I can't go up 5 and left 1. So I'm just going to draw my line here. See if I can make it a little bit better this time. Oh yeah, that one was better. We get the idea. Okay, so why would I use these two examples? Well, one, they're both negative values. And you'll notice, as opposed to the last example, both of these are going downhill now. So if I start over here on the left, right? My little dude doesn't have to walk up the hill anymore. Now he's going to be sliding down. The key word there is down, because that's what a negative will do to your slope. It will cause it from going up at an angle to going down at an angle. Now remember, slope means steepness. So when we're referring to a slope, that means how steep is the line. Well, let's see. If I'm sliding down this line, that doesn't look like that terrifying of a slide, right? I kind of be cruising along, can look at the scenery, feeling pretty good. I'm probably traveling at a pretty decent rate. Imagine this slide. You're going to be flying down that thing because it is so steep, like you're probably going to get burns on your back. Am I right? So this is a line that is more steep, and this is a line that is less steep. Why is that? Well, if you look at this slope, this was a slope of -2/5. This was a slope of -5. Which one is larger? Now notice I didn't say which one is greater. Which one's like literally, which one's the bigger negative number? -5 is a bigger negative than -2/5, which means -5's line is going to be steeper. It's going to be more steep, almost vertical, whereas -2/5 is like, moving along, feeling okay. So the larger the slope, the steeper the line. That's the lesson from this. Okay, let's go ahead and take a look into our IXL practice. Now, once you log into your IXL practice, we're going to sign in here. Yep. And your code for today, let me look up that code. Slope. Is this it? Yes, your code is FSU. FSV. FSV. So if I go up to the search bar, FSV, you'll see this line, graph a line using slope, FSV. Okay, now these start off with just one quadrant instead of all your quadrants, and you have this little cursor with the little point. So really, what this does, is this allows you to put a point in the coordinate plane somewhere. Click, click. So we're starting with the point 4, 3. 4, 3. I place a point. Now here's the cool part. As I start to move around, what? It's already planning where my line's going to go based on the slope. Now remember, the slope is just a fancy way of saying the rate of change. So when you're given that the slope is 1/4, that's the same thing as thinking about it in terms of the rate of change. That's just how steep the line is. But to figure out the actual values, that looks pretty terrible, you consider this as a change in y over a change in x. So a slope of 1/4 means my y is increasing by 1 as my x is increasing by 4. Notice how I said increasing? That's because these are both positive values, which means I'm going to go up 1 and right 4 to get to the next point. So here's my point. I'm thinking, okay, I'm just going to go up 1 because my y has increased from 3 to 4, and I'm going to go right 4 because my x has increased from 4 to 8, right? 3 plus 1 is 4, and 4 plus 4 is 8. That's what all that means. Now, you don't have to do all that. All you have to do is go, okay, from here I go up 1, 2, 3, 4, click, and your line has formed. That's how cool that is, right? Now, here's the cool part. Even cooler part, right? There's so many cool parts. You can actually check using the rate of change, using the slope to see that your line was correct. Instead of going up 1, what if I went down 1 and right 1, 2, 3, 4? Look at that, another point on your line. That just solidifies that you know that you most likely did this correct. Let's submit. Looks good. Okay, let's clear this out, clear all drawings. Here we go, let's take a look at another example. All right, graph a line that has a slope of 6 and includes the point 0, 1. So we start with the point 0, 1, 0 on the x, 1 on the y. By the way, this is something called a y-intercept. We're going to learn about that in just a little bit. Okay, now if I look here, the slope here is 6. So my change in y over my change in x, and yeah, I write this every time, is 6. But 6 as a ratio is 6 over 1. These are both positive, meaning I'm going to be going up 6 and right 1. So from here, my y goes 1, 2, 3, 4, 5, 6. My 1, I add 6, it ends at 7. And I'm going 1 to the right because I'm going from 0 to 1. Let me grab my mouse here. Up 6, right 1. Can't go any further in either direction. Click submit. and it tells us we did a good job. Look at that. Now, without the drawings, this is what you could do. Start at the 0.07. My slope is 2, which is equivalent to 2 over 1. So I'm going down, 1, 2, no, down. Why did I say down? Silly Miss Angel. You're going up 1, 2, and right 1. And there's a slope of 2 over 1. Okay, let's see if it gives me something different. This one's a slope of 7. If it doesn't give me a negative on the next one, I'm going to jump. Let's see, 0, 3, slope of 7, which as a slope is 7 over 1. So I'd be going up 1, 2, 3, 4, 5, 6, 7 over 1. See how steep this line is compared to the last one we did? That's because 7 is a greater slope than 2. Like the steeper, the larger the slope, the steeper the line. All right, now this one gives me a slope of 1/3. Compared to the last one, that means it's not going to be very steep. So if my point is 3, 2, and my slope is 1/3, this time my change in y is 1. So I'm going up 1. My change in x is 3, to the right 3, 1, 2, 3. There's my line. Now again, here's the cool part. Here's how you can check your work. I went up 1 and right 3. What if I did that again? Up 1, right 3. There's another point on your line. What if I reversed it and went down 1, left 3? Look, there's another point on your line. I know, it's so cool, right? That's what you're all saying. Oh my gosh, Ms. Angel, this is so cool. Click submit, and we're doing pretty good here. Okay, now these are all giving me examples that are positive slopes. So I'm gonna find one that's a negative slope because we've done enough positive slopes. Okay, here we go. That didn't take too long. So now we have a slope of -3 that includes the 0.05. So from here, starting at 0.5, I'm gonna grab my drawer. Here we go. So remember, a slope of -3, slope is just another word for rate of change, and the rate of change is always right. So change in y over change in x means that a slope of -3 is equivalent to -3 over 1. So a negative change means I'm going down 3. So from 5, subtract 3, that means I'm going from 5 down to 2. But my change in x is still positive. I'm still changing to the right 1. I'm still adding 1 each time. So that takes us to our next point. So I went down 3, right 1. It doesn't look like I can go very much further. That's a decently, steep line. Hit submit, and there you go. Okay? All right, now this is an interesting one, a slope of 0 that includes the 0.6, 9. Let's try this one. So I go to 6, 9, and a slope of 0. What? Can you have a 0 slope? Let's see what that looks like over here. So change in y over change in x. Let's see. 0 is just like any other whole number. To change 0 into a fraction, you can do the same thing. Just put it over 1. Now, usually this means this is our vertical change, like we're changing in y. But what does it mean to add 0? I'm pretty sure that means there is no change. Like 2 plus 0 is 2, plus 0 is 2, plus 0 is 2. So there's no vertical change, but look at this. I'm still adding 1 on the x. So from here, I'm not going up, I'm not going down. So I have no change in either of those directions. All I'm doing is I'm going to the right 1. And there's a point, and then I can go to the right again. And there's another point, and to the right again. And another point, and to the right again, and there's another point. Or I could go to the left 1, and another point, left 1, right? So let's grab our mouse from here. It's called a horizontal line, and here's why. If you have 0 steepness, that means you're walking along flat land. So if this is my little dude, see if I can draw a little stick figure here, and he's walking along, there is no incline. 0 slope means 0 steepness. That's supposed to say steep, and it doesn't, and I'm sorry. No, that looks like my 5-year-old nephew, right? But not steep. I'm gonna take that out because that's terrible. But you get the idea. 0 slope means it's not steep at all. You're walking on flat land. Let's go ahead and click submit before I embarrass myself anymore. Click submit, and there you go. All right, let me clear all these drawings. I'm gonna jump a level here because we've been working kind of with the same idea. Ah, look at this. As soon as you get into the 70s, now we're dealing with all 4 quadrants of the coordinate plane. How fun. So 0, 4 is our point. Our slope is 2/7. So again, that means up 2, right 7. So up 1, 2, right 1, 2, 3, 4, 5, 6, 7. There's my other point. And look, if I were to have gone down 2 and left 7, there's another point on the line. Crazy, right? Click submit. Now we have a point. Oh, look at, I can do this again. I have a slope of 1, 6, starting at the point -6, 7. This time I'm going up 1, 1, 2, 3, 4, 5, 6. Did I believe that? 1, 1, 2, 3, 4, 5, 6. And if I did it again, up 1, 1, 2, 3, 4, 5, 6, it leads me to another point. Submit. Cool. This time I have a slope of 10, which means, let me clear all those. That's the same idea as 10/1, which means I'm going up 10, right 1. So when I start at 0, 0, up 10, right 1, look how steep that line is. Can you imagine hiking up that thing? No, thank you. Oh, goody. I was hoping we'd come to another negative. I like negatives if you haven't been able to tell. All right, what does this mean? This means if it's a -1/9, remember, give that negative to the numerator because the rate of, because the rate of change is always right. That just helps me remember. 9. That means this is a negative slope over a positive, or negative y to a positive x. So I'm going down 1 and right 9. So let me grab my mouse. Starting at 0, -1, that was our point. I'm going down 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9. And here's how you can tell, is it going down? Because if it's negative, I'm thinking about it going downhill, and it's 1/9, which is not very steep. So I should be, this is like a very easy downhill, a very easy slide. All right, look at that. Now this is a little bit larger of a fraction, which means it's not going to be as easy of a slide. So from here, if I go to -5, 10, I'm going down 6, 1, 2, 3, 4, 5, 6, and right 5, 1, 2, 3, 4, 5. Now notice this one compared to the last one was a very easy decline. This is slightly steeper. Like this would be a faster slide because it's a larger slope. Look at that, okay? This one's gonna be even steeper because it's a larger slope. Now let's go on a little bit. I'm gonna jump a level here to the last one to wrap up this video because it's been a while. This is where things get interesting, okay? Feel free to stop at a SMART score of 90 if you don't even wanna go here. You don't have to go this far. But what's interesting here is it brings in this concept called a y-intercept. A y-intercept means a point on the y-axis. So when it says the y-intercept is 3, we're going to get into this in more detail next week. That means the point 0, 3. That's where the line crosses the y-axis, which means it's where x is 0. So the point that you're going to start at is right here, 0, 3. And then a slope of -7/3 means I'm going to go down 7 and right 3. So let me grab my mouse, okay? Starting at 0, 3, down 7, 1, 2, 3, 4, 5, 6, 7, and right 3, 1, 2, 3. That's what your line looks like. So y-intercept means point on the y-axis, okay? Let me clear all that out. Look at that. That's a pretty steep line because, again, -7/3 is a pretty big negative number. Okay, same thing here, y-intercept of -4, that means on the y-axis, the point 0, -4. So I'm going here to 0, -4, and then a slope of -1. What does that mean? That means, whoops, that's the same as -1/1, which means I'm going down 1 and right 1 from there. So let me grab my mouse from here, down 1 and right 1. That's not a terribly steep line, but it's not bad, right? That looks like a pretty decent slide. Submit. You get the idea. All right, those are the only examples I'm going to give you. The rest of this you can do on your own. Just remember, slope means steepness, but it's the same ratio as rate of change. It's how change in y is affected by change in x. If you have any questions regarding your IXL code, please don't hesitate to ask. Mr. Adams and I are here for you during this time, and we will post the SMART score breakdown in the assignment along with this video. So have fun with our new concept of slope, and I'll talk to you all soon.